Okay, students, next is we will discuss about exponential and logarithmic function, right? So in class 11, you might have remember in limits, we have done some identity based on exponential and logarithmic function, right? If you remember, limit x tends to 0, we have done e to the power x minus 1 by x. What it is? It was 1. Same way for log also we have identity, right? Using those identity we can prove this derivative. You can see derivative of e to the power x is always ex. The derivative is given in the book also. Using this only you can easily prove it. Okay, you need to use that principle of derivative which we have used in class 11. Same way you try to use that, you can easily prove this will be equal to e to the power x. Okay, if you want to see, you can see the derivative there. You can also understand, very simple it is. Okay, so for log also, derivative of log x is equal to 1 by x. Actually this derivative I have already given in class 11, but we didn't explain well this one, right? We didn't understand well that one there. The reason is, in that case, derivative we have introduced for the first time, so you might not understand the derivation of this one, right? So you can see the derivative given in the derivation is given in the textbook of this one. Okay, so you can see that. So derivative of ex, you just remember it is always ex, e to the power x only. Okay, derivative of log x is always 1 by x. Derivative of log x, when it is x here, it is 1 by x. If you have different function here, in place of x something different you have, then you have to derive that again. Okay, so in this case also, in place of x, if you have something else, you have to derive that again. Now based on that, again some property of logarithm, log of p into q is always summation plus of log p plus log q. Okay, when it is product, it will be addition, log of p plus log of q. Then log of p square is always, I can write this power as coefficient, like derivative of x square x cube. Remember, same like that only, but these are not derivation, these are properties only. Okay, log of p square is 2 log p. This power come as a coefficient. Okay, 2 log p. Clear? Now if I use the first property here, it is like log p into p. Can I write like that also? P square, can I write p into p? If I use that property, then I can write this one as log p plus log p also. Okay, same for n power. For n power, this n will come as a coefficient log p. Now here also you can write log p plus log p plus log p plus log p till n times you can write down that one. Okay, that also you can use here. So last one is for division. So log x by q, x by y is equal to always log x minus, whenever it is division it will be minus. In case of product, plus. In case of division it will be minus. Okay. Now using this property and this derivative, we can solve the problems there. We will discuss more on log. Okay, afterwards we will discuss more on log. Now for the time being, we will just discuss this two first, and your exercise 5.4 is based on only this derivative. So let's see, derivative of ex, if it is ex, derivative of log x if it is 1 by x. Then what kind of derivative we will have if you have different kind of function in place of x and in place of x here. Okay, so we will try to solve some question from your exercise 5.4. Based on this only we can do this. So exercise 5.4, question number 1, what it says, very simple proof, like previously we have solved, same way we will prove here also. The only thing is, this time exponential and logarithmic function will be. So in your question it is given, you have to differentiate this one with respect to x. So your independent variable is here x, right? So if you want, you can write let y is equal to ex by sine x. Now you can find, you have to differentiate this one with respect to x, right? Means you can find dy by dx, means you have to differentiate this one with respect to x. So differentiating with respect to x, what we will get, dy by dx is equal to dx ex by, now if you see well, what function is this? This is like u by v form, right? This we have already done, u by v form, quotient rule, right? We have to use here. So u by v form, what was the derivative? Sine square x, denominator v square always, right? So v I will leave as it is. We will differentiate u e to the power x, then minus, in case of division always remember minus will come. Okay, next I will keep ex as it is and will differentiate sin x. Okay, exactly same way, just we have learned here is what is the differentiation of ex. You know it's ex only, so the numerator you will get sin x, ddx of ex is ex only, minus e to the power x ddx of sin x is cos x, okay, by sin square x. So from here you can take ex common, right? You will get sin x minus cos x by sin square x. That's it. After that no more simplification, so this will be your answer. Okay, so your next question is question number 2. What it is? Exponential function, right? Again, so e to the power sine inverse x. So you can see in place of x now, you know, this time also you have to find derivative of this function, okay? Differentiate this one with respect to x. Now when we will differentiate this one with respect to x, we know that e to the power x, what it is? E to the power x is e to the power x only, right? So in place of x you have different function again. So what you will do, you have to differentiate that one also again, right? So how we will do this? Let, you can write y equal to x. Okay, so differentiating with respect to x, we get dy by dx. Basically we are finding dy by dx, means differentiation of y means this one. Okay, d dx of e to the power sine inverse x. Okay, so we know that d dx of e to the power x, what it is? It's always e to the power x only, but in place of x you can see it is different function now, so you have to differentiate that one again with respect to x. Now remember I asked you to differentiate all the inverse trigonometry function. This is the reason. Okay, if you remember that one directly also you can write down, and if you don't remember then you have to do here separately again. So d dx of, okay, those who have not done this one, so for them again you have to do this one separately. 1, now this I will differentiate separately. d dx of sine inverse x, we have to find this one, right? So what we will do, let, we will take it t is equal to sine inverse x. Now what we have to find? dt by dx, right? That's what we have to find. So differentiate t with respect to x, that's what we have to find. See, this I have taken as suppose t, so what you have to do, d dx of t you have to, means differentiate t with respect to x you have to do, right? So this what you can do, so see here, first thing, this make it simple function here. So what I will do, sine I will bring this side, sine t is equal to x. Now you can easily differentiate this one, right? So I have to find dt by dx. So here I can find out differentiating with respect to x. Those who have not done this one, in the previous exercise only as an extra question I have given this one to solve this one. This is very simple one. Okay, those who have not done, you can see here, sine t is equal to x. Now I can easily differentiate d dx of sine t is equal to d dx of x. So this will be cos t, this will be 1. Now this, in place of x you have t, so dt by dx also will come here, right? So dt by dx, I have to find this only. So cos t, bring this side, 1 by cos t. Now cos t, what I can write? Can I write in terms of sine t, so that I can write this one in terms of x only. So 1 by 1 minus sine square t is equal to 1 by sine t is equal to how much? X square. So sine square t will be x, sorry, sine t is equal to x, so sine square t will be how much? X square, right? So your dt by dx is equal to how much? 1 by 1 minus x square. So you can remember this one as a formula also. Always remember, differentiation of sine inverse x is always 1 by 1 minus x square, square root of 1 minus x square. Okay, so after this you can write down, therefore 1 implies, so we find out, right, dt by dx, that is dt by dx means what? T is what here? Sine inverse x by dx is equal to this one, 1 by 1 minus x square. So we have got d dx of sine inverse x. So 1 implies dy by dx is equal to how much? E to the power sine inverse x by into 1 by 1 minus x square. Okay, so this will be your answer. After this you cannot simplify. E to the power sine inverse x into 1 by square root of 1 minus x square. So you can write e to the power sine inverse x by directly square root of 1 minus x square. Okay, so this is for those who have not done this differentiation which I have asked you. If you have done and if you remember this one, then you can directly put here in place of ddx of sine inverse x. Directly you can put, you will get exactly whatever marks it's provided here in this question. Okay, the one who will do and show it this one, they also will get same marks, and the one who you have written directly also will get same mark here. Okay, next question number 3, e to the power x cube. So you can see this is also of the form exponential form function, right? E to the power x form, but in place of x you have x cube. So you will differentiate this one again. So differentiating with respect to x, directly we will do, I will not write y. You can do like this also. You can see x cube, directly you can write this and then can proceed. ddx of, sorry, ddx of e to the power x cube, what it will give? Now it is of the form e to the power x, so if it is in the form e to the power x, it will always give you e to the power x only, right? This will come out, right? But in place of x, since you have x cube, so you have to differentiate that one again, chain rule. So this will give you e to the power x cube, this will give you 3x square. So this will be 3x square e to the power x cube. This is the differentiation. Okay, so there are some more questions. You can try that one. I will show you in the next video. Okay.